What's up? How's everybody doing? All right, we got us a logarithmic equation to solve. All right. So the one thing that you want to do when you're solving logarithmic equations, you want to just think about this. You got two different things you want. You want a single log equals a number, or you want a single log equals a single log. You want one of those. All right. So remember, you've learned how to expand and condense logarithms. All right. You learned how to go from logarithmic form to exponential form to logarithmic form. You've learned all that. So let's get it in one of these two ways. So if we look on the left-hand side, you notice you do not have a single logarithm there. On the right-hand side, you do have a number. So we're good over there on the right-hand side. But the left-hand side, we need to rewrite that as a single log. So to do that, we've got the log base 6 of x minus 1 times x minus 2. Remember, when your addition comes together as multiplication. Okay? Remember, there was a property you learned that says the log of m with base b plus the log of n with base b is equal to the log of m times n with base b. Okay? I mean, this side might have been written first, but it doesn't matter. You can go either way. So in other words, if it's addition that comes together as multiplication, you multiply the two things that you're taking the log of, and that's what we did here. All right, and that is equal to 1. So now we got the log base 6 of x squared minus 3x plus 2 equals 1. Oh goodness, so what did we do there? Well, we foiled it, right? First, outside, inside, last. X times x is x squared. Then we've got negative 2x plus negative x is negative 3x. And then negative 1 times negative 2 is positive 2. All right, so now, we've got this right here. We've got a single log equals a number. Okay, so what we're going to do now is we're going to change this to exponential form. So remember, you had a property that says the log of x with base b is equal to, let's just say, y. Then that means b to the y equals x. It's the base of the log raised to that power equals x. So the base raised to the first power, so 6 to the first equals that. So we've got 6 to the first equals x squared minus 3x plus 2. All right, so 6 to the first power, that's just 6. So let's just rewrite it. X squared minus 3x plus 2 equals 6. Because that's not going to always be an exponent of 1. Okay. All right. And I just wrote all the x terms on the left-hand side. I wrote this side over here. I just like to have the x part. I like to have everything on the left. Okay, it's not a big deal if you leave everything on the right. So now we've got a quadratic equation to solve. So we're going to subtract 6 to both sides. So that's going to give us x squared minus 3x minus 4 equals 0. And do we know how to factor? We need to know how to factor, and I'm sure we all do if we're at this point. So let's just come up here. I'm just going to rewrite the equation up here. All right. All right. So now let's factor. So I've got x minus 4 times x plus 1. So x minus 4 equals 0, or x plus 1 equals 0. And so I get x equal 4 or x equal negative 1. All right. All right, so let's take a look at this. All right, so the thing that you've got to remember here is you cannot take the log of a negative number. So you have to check your solutions. And you don't have to go as far as when you're checking your solutions. And look, if you're still watching the video, don't stop the video. Watch till the end, because this is important. Okay? All right. So you got to plug both numbers back into your equation. You don't have to necessarily check that you get the same thing on both sides. You've just got to take them, plug them in, and make sure you're not taking the log of a negative number. So look at this. If we plug the 4 in, plug the 4 into here and here. So 4 minus 1 is positive 3. 4 minus 2 is positive 2. So that's good. That one works. Now take the negative 1. Plug it in for x. Negative 1 minus 1 is negative 2. Can't take the log of a negative number. The negative 1's not a solution. Okay? Still, if you're watching, still don't stop it, because I've got another point to show you. Okay? So, I mean, once we see that we're taking the log of a negative number here, we don't even have to plug it into there, because it violates the rule right here. Now, you might be thinking, well, I took this and I rewrote it like this, and if I take the 4 and plug it into here, that's positive. If I take the negative 1 and plug it into this, well, that's positive too. It works in that one. So why isn't it a solution? Guys, good question, huh? Have you ever thought about that? All right. You can't plug it into this one. Okay? These two, they're equivalent, but they have different domains. Okay? So let me just show you with this example here. Well, let's just look at this. So we can have the graph of this. Okay? Let's say we have y equals 2 log x. Okay? 2 times the log of x. Well, that is the same thing as, or it's equivalent to y equals log x squared, right? Well, if you look, this y equals 2 log x, that is this graph. Okay? This one down here, that graph would look something like that. So you can see their domains are different. So whenever you're solving a logarithmic equation, you have to plug the solutions back into the original equation, not the one that you condensed or wrote as a single log. You can't plug it back into that one. You have to go back into the original. And you can't even plug it, you can't plug it into that one either. Because if we plug, just think about it, if you plug the negative 1 into here and negative 1 into here, you got a negative times a negative is positive. You can't do that. You have to go back to the original. All right. So if you stayed the video to hear this part, leave me a comment. Let me know. I want to know how many people actually watched till the end to hear that explanation there. All right. So I appreciate you watching. Check out my other videos. Give me a like, share, subscribe, comment, and I will see y'all in the next one. Later.